All right, we're going to be discussing Chapter 6, Lesson 4, Notes, Adding and Subtracting Polynomials. So you can add or subtract polynomials by combining like terms. So let's look at a couple of different terms. 4y and 7y. If you look at those are like terms. What you do is you look at the variable, and the variable has to have the same exponent. So there's no exponent there, which means the exponent is 1. And there's no exponent here, which means the exponent is 1. So since they have the same variable, they're both y's, and the y's have the same exponent, then you basically just go 4 plus 7, which is 11y, and that's the answer. All right, let's look at this next example. 8x squared and 2x squared. So if you see, they both have an x, right? But they have the same exponent. This is squared and this is squared. So these are also called like terms. So to combine them, you just add the numbers together, 8 and 2, which is 10, and then you just add that x squared on. So it'd be 10x squared. That's what those equal when you add them. And then lastly, let's look at 7m to the 5th and m to the 5th. So they have the same variable. They both have an m, and the m is raised to the 5th power here, and the m is raised to the 5th power here. So they are like terms as well. So you add the numbers. So there's a 7 here, and there is no number, but when there is no number, you know that there is a 1 there. So it's 7 plus 1, which would be 8, and then you just m to the 5th power. Okay, that's what that would be if you added them. So those are like terms, okay? So basically what you need is you need the same variables raised to the same power. That's what being like terms are. So the same variables raised to the same power. So let's look at some things that are not like terms. I'm really having a hard time highlighting in the box. Okay, just bear with me on that one. All right, so let's look at some things that are not like terms. So 3x squared and 3x. Why are these not like terms? They both have an x, but if you see, this is raised to the 2nd power, and there is not a number there, so you know it's raised to the 1st power. So they have different exponents, so that's why they're not like terms, and you cannot combine them. So it's the same variable with a different exponent. What about this one? 4y and 7. These are not like terms. Now, why are they not like terms? Well, this one has a variable, and this one does not have a variable. This is just a number. It's a constant, right? Remember that word constant? That's for just a regular number. They use that word constant. So we have one with a variable and one constant. So they're not like terms, so you cannot combine them. It would just be 4y, and 7. What about here? 8m and 3n. Why are these not like terms? Well, they have the same power. There's a 1 there, and then there's a 1 there, right? When there's nothing written, there's a 1. But the variables are different. Here's an m, and here's an n. So you cannot combine them. So even though they have the same power, right? They have that exponent of 1 and 1, but they have different variables, so you cannot combine them. All right? So that's just kind of looking at things that are like terms and looking at things that are not like terms. All right, so now we're just going to talk about adding, okay? So whenever you add, you can only add things that are like terms. So when I'm looking at this, 3x squared plus 4x plus 5x squared plus 6x. So what are like terms? So what I'm seeing is I'm seeing this x squared. So that is an x squared, and here's an x squared. So I can add those two things. Also, I see that there is a 4x, and there's a 6x. So they're both x, and they have an exponent of 1. So I can add those things. So I would first do the one with the highest degree. So 3 plus 5 would be 8x squared. And then I would go, this is a positive 4, and that's a positive 6, right? So 4 plus 6 is 10, so it would be a positive 10x. And that would be the answer. That's how you add and you combine like terms with this polynomial. All right, let's look at the next one here. So it looks like there's this is grouping this trinomial, right? Remember when there's 3 terms in a group, that's a trinomial. And it's adding to this other trinomial, right, that's in a group. So what I notice here is that there's a plus sign. Whenever there's a plus sign outside of a parentheses, you can just drop these parentheses. And the reason why is if you distribute this plus sign, a plus times a positive is just going to be a positive times a positive is a positive times a positive is a positive. So all the signs remain the same if you were to distribute that positive to everything in this group. So the moral of the story is when you see that plus sign and there's no number here, see how there's no number? There's a 1, right? But 1 times anything is just anything. So whenever you see this positive sign, you can just drop the parentheses. And here there's parentheses, but there's no number in front, so you can just drop the parentheses as well. So what we end up with is 5y squared plus 7y plus 2, like these parentheses are really unneeded, plus these parentheses are really unneeded, so I can just rewrite everything. Okay, so this is what we're working with. Now we just want to combine like terms. So what I see is there's a y squared, right? So here's a y squared. And here's a y squared. So those are like terms, the same variable and the same exponent. And then what else I see is there's a y. There's this. So those are like terms. And then lastly, I see that there is a number, right? So I'm going to start with the highest degree. So the y squared. So I'm just going to go 5 plus 4, which is 9. Y squared, and this is a positive 5 and that's a positive 4, right? That's why I add them. Then I'm going to go to the y, which would be the next highest degree. This has a degree of 2, this has a degree of 1, the constants have a degree of 0, right? Just a refresher of last class. So I'm going to go 7, right, when I'm looking at the y, 7, and what's the number here? There is no number, but whenever there's not a number, that means there's a 1. So 7 plus 1, because they're both positive, is 8y, and then just the constants. 2 plus 8 is 10. So that is our answer. Perfect. Okay, let's go ahead and look at the next page here. So what we're going to be doing is we're going to be looking at these, and I would just want you to take a second and look at 1, 2, and 3, and I want you to determine whether they are like terms and explain why they are or why they're not, okay? Here's my friend the pause dragon. Remind you to pause your device. Go ahead and work out those 3 problems, 1, 2, and 3. When you get done, press play, and we'll talk about them. All right, see you in a bit. Okay, let's see how you did. So for this first problem, what I see is there's an x here to the first power, and there's an x here to the 4th power. There's the same variable of x, but they have different exponents, so they are not like terms. So these are not like terms because the same variable, but different exponents. Kind of running out of space there. Did you see that? Oh, I bumped it, sorry. So yeah, not like terms because same variable but different exponents. All right, let's look at this one. 5y plus and 7y. So here we have a y and we have a y. It's the same variable and the exponent is 1 and 1. So this would be, yes, like terms. Because same variable and exponent. So that's what you need. You need the same variable and the same exponent to be like terms. Perfect. If you got that one right, great job. Let's look at this next one. 2z to the 3rd and 4x to the 3rd. They like terms, not like terms. They are not like terms because they have a different variables. So if you got all three of those right with the explanations, great job. If not, go ahead and fill in so our answers look the same. Okay, now what I want to see is I want to see if you can do problems 4, 5, and 6 only. 4, 5, and 6 only. So here's my friend, the pause dragon. Remind you to pause your device. When you get done, press play, and we'll go over it. Okay, let's see how you did. So let's look at number 4. Okay, we need to combine like terms. What I see is this 2y squared and this y squared. I also see this 3y and 7y, same variable, same degree. Okay, those are like terms. So first we're just going to add the numbers. So this is a 2. There's no number, which means there's a 1. So 2 plus 1 is 3. 3y squared. And then we have the 3 and the 7. 3 plus 7 is 10. So it's a positive 10y. That is the answer. So if you got that right, great job. Okay, let's look at 5. So 5, we have m to the 4th power here. And we have another m to the 4th power, and it's negative. So we need to take that into consideration. And then we just have this 3m, right? But there's no other m, so that's just going to be there. So we're going to combine like terms with these m's to the 4th power. We have 8 minus 4. 8 minus 4 is just 4. M to the 4th power, right? We're always starting with the one with the highest degree. And then we just go plus 3m. We can't combine these, right? Even though they have the same variable, they have different exponents. This is a 4 and this is a 1. So when they have different exponents, you can't combine them. Oops, sorry about that. I bumped it. Yeah, so that's the answer. So if you got that one right, great job. If not, just go ahead and fix. No problem. Okay, let's look at the next one. I see x to the 5th power, 12x to the 5th power. That's the only one. So I'm just going to highlight that. And then I also see 10, I see x to the 4th power here, and I see here, okay? So we're just going to combine like terms. There's nothing else that has x to the 5th power, so that's the highest degree. So I'm going to write that first because I'm trying to write it in standard form, right? Highest degree, and then the next one, and so on. And then here we have x to the 4th, so this is a positive 10, so we're going to go plus 10, and this is a positive 8, so 10 plus 8 is 18, so it's a positive 18, x to the 4th power, and that is the answer. So if you got all three of those right, great job. Okay, now let's move on to 7, 8, 9, and 10. I want to give you some time to kind of go ahead and work out those problems. So where's my friend? Here's my friend, the pause dragon. Remind you to pause your device, work out 7, 8, 9, and 10. When you get done, press play, and we'll talk about them. All right, see you in a bit. Okay, let's see how you did. Okay, where are we at? All right, we have this positive outside of the parentheses. It's just a positive 1. So those parentheses aren't needed. Also here, there's nothing outside there except a 1, so these parentheses aren't needed. So I'm just going to rewrite the problem without the parentheses. Okay, now I just need to combine like terms. So I see that there is an x squared here and here. Okay, those are like terms, and I also see that there's just a plain x. So 3x here and 6x there. So we're going to start with the highest degree, which would be the x squared. So basically just 6 plus 2, which is 8, x squared. And then here we got 3 plus 6, which is 9x. And that is our answer. So if you got that one right, great job. Let's move over here. Again, there's no number in front of here except a 1. So those parentheses really are unneeded. And here we just have a positive, again, a positive 1. So these parentheses are unneeded. So we're just going to rewrite that problem first without the parentheses. And then just combine like terms. So I see the highest degree would be this m squared. And that's really just it, right, by itself. And then I see an m, right? There's a negative 10m. And then there's a positive 8m. And then we just have some constants. We have the 5 and the 2, and they're like terms as well with each other because they're just numbers. Okay, now we're going to start with the highest degree, which would be that m squared. So we write that m squared, and then we have the variable m to the first degree. So we have a negative 10 plus 8. So negative 10 plus 8 would be negative 2m, and then 5 plus 2 is just 7. That is it. So if you got that one right, great job. Let's go ahead and move on with 9 and 10. Okay, so again, there's no number in front of this parenthesis, and this is just a positive 1. So these parentheses aren't needed, so I'm just going to drop the parentheses and just rewrite the problem. Okay, perfect. Now we are, what are we going to do? We're going to figure out what are the like terms. So I see this x cubed, right? We have this 6x cubed here, and we have this 4x cubed here. I see an x squared, which is here. And what else do I see? I see an x, right? We have 5x and negative 2x. Those are like terms. And then lastly, we have that constant, which is just a positive 9 here. Okay, so let's just start with the highest degree, which would be that x cubed, I'm sorry. So that's 6 plus 4, which is 10, x cubed. And then we go to the next one, which would be x squared, but there's nothing else besides that one, so we just rewrite that as positive. And then we go down to the ones that are degree 1, which would be 5x minus 2x. So it's basically just 5 minus 2, which is 3, and it's a positive 3, right? X. And then lastly, that constant, which is just plus 9. And yeah, that's it. That's how you add polynomials. Okay, on to the last one, number 10. It's a doozy. It's a big old problem, but we can do it. So these parentheses here, there's no number here. There's a 10 there, but that's just the problem number, right? 7, 8, 9, 10. Okay, so that isn't in the problem. It's just counting the problem. There's just a 1 there, so those parentheses aren't needed. And then we have a positive here, positive 1, which means these parentheses aren't needed. So I'm just going to rewrite the problem first. Okay, perfect. Now we're just going to combine like terms. So I'm going to start with the highest degree, which would be that y to the 5th, right? So we have a 2y to the 5th here, and then we have a y to the 5th here. And then what else do we have? We have a y to the 4th, which is right here. There's only one of them. And then we have a y cubed, which would be right here. This is a negative 6y cubed. And then we have a negative 2y cubed over here. And then we just have some constants. We have a positive 1 and a negative 1. All right, so we just need to combine like terms. So we're going to start with the highest degree, which would be this y to the 5th. This is 2 plus 1, which is 3. Y to the 5th, and then we would go to y to the 4th, right, which would be the next one. And there's nothing to combine, so we just write it just how it is, plus 8y to the 4th power, and then the next one in highest degree would be the y cubed, which would be negative 6 minus 2, which would be a negative 8. Y cubed, and then are there any y squareds? No, there's no y squared, so after the y cubed, it just looks like there's the constant, plus 1 minus 1, which is 0. So this is it. This is our answer. So if you got all of those right, you did a wonderful job, and I'll see you in a little bit with the next example.